Hey, this is Pankaj here, and I talk about a very interesting topic today. And the topic is how data science and machine learning engineer plan their day-to-day activity. So, what they do every day, right? So, let's see that. So nowadays, I'm mostly talking about the finance domains. I take an example of that, right? And I talk about a data science and machine learning engineer day-to-day work, right? So I have bifurcated the overall work structure of data science and machine learning engineer based on their experience as well, right? So experience also take a very important role here, but these are the four segments, you can say that, where the data engineers planning their day-to-day activities, right? So first one is continuous knowledge acquisition. Very important, right? It's very important if you are working as a data scientist or a data engineer, that you need to continuously acquire the knowledge, right? So when I say continuously acquire the knowledge, so I further broke down this into these categories, right? Continuous knowledge acquisition of domain knowledge, right? So you are working in finance domain, so you should have a very clear understanding about which specific segment of finance you are working, right? So you need to have a very good domain understanding of it, so that if you are proposing a solution, that should be aligned with which area you are working, right? And then the next is data wrangling. So you as a data scientist or data engineer work with a use data, right? So and you want to infer information from that data, you want to infer some pattern from that data, right? So data wrangling is very important. And then statistical analysis, so hypothesis testing comes under it, and inference testing, inference statistics comes under it. So statistical analysis is also a very niche skill which is required to work as a data science, right? And then technologies, and you need to be very passionate about learning new technologies, right? So when I say technologies, then there are big data technologies, right? So for use data, unstructured data. So right now in the world, the data is not just like file kept somewhere, or you can say that in a relational data where we are mapping the entities, right? And the relation between those entities are kept, right? So that's not only the data. The data is this visual, which right now you and me are interacting. This is also a data. So it is unstructured data, right? So you are sharing something, you are commenting somewhere, right? And you are liking, you have your behavior, you are buying, buying behavior. So everything is data, right? So you need to work on this set of data and infer a pattern from that data. So big data technologies are very much used in this segment of in this segment, this data science and machine learning. And you need to look for machine learning algorithms. So where in my data set which algorithm is fitting, right? So sometimes you want you need to make some predictions, choices, right? What kind of machine learning algorithm I should apply on this data set. So these come with experience, right? So initially you will work with very limited scope, where you are just wrangling the data, and you are setting up, you are doing some exploratory data analysis, right? In data, right? And but later on, in later stage, when you are experienced, so you have to come up with a model which is actually solving a business problem, right? So there the machine learning algorithm comes, right? Web development framework. So just keeping that model is somewhere and doing that, doing the prediction from that model in your standalone machine doesn't solve the purpose, right? So you need to expose that to the the outer world. When I say outer world, means you to your client. So how you are exposing that functionality to your client, and how much scalable that is. So web development framework, right? So you need as a data scientist, you need to work on different web development technologies as well, right? Data visualization, very important aspect. So you talk to multiple people. You talk to even a head of a department, a subject matter expert. As a data scientist, you talk to very different stakeholders at the client side, right? And even if the CEO of your company are proposing something, right? So you work with those people. They do not understand technology. You cannot go there and just show them a code, right? What this code is doing. So you need to give them a business value. So why you are doing this, right? So their data visualization comes into the picture, right? So when you the storytelling part, right? And even to understand things better, right? So the Python, Tableau, these are the technologies which are used widely in this segment, right? Communication skill, as I told, you will be talking with multiple people. Even you will be talking with your customers. You will be talking with your higher authorities. You will be talking to different stakeholders. So your communication skill and the storytelling skills should be very good, right? So this also comes under the continuous knowledge acquisition. So when I'm saying continuous, that means as soon as you are gaining experience in that, you should be better in that, right? Business acumen. So you need not to be a employee who is directed by who is directed by their manager and just following a line, right? So you should have business acumen. So if you would have been the owner of this business, so what decision you can take? So that kind of footing you should have also in your mind, right? So that business acumen is also required when you are working in data science. You are working as a data science and machine learning engineer in an organization, right? And this comes under the day-to-day work of data scientists, where the data scientists or the data engineers are continuously acquiring the knowledge about domain, about they are enhancing their communication skill, talking to multiple stakeholders. They are representing the data in a form which is very much understandable by the stakeholders, right? They have business acumen. They know the what technology should fit in this use case, right? And there are a lot of, right? So this is the first segment. The second segment is exploratory data analysis. So it is most important step. Why I'm saying it most important step, the data wrangling comes under it. So what does data wrangling means? You have a huge set of data, structured and structured data. So you are cleaning that data, right? And let's suppose the you when you are cleaning that data, so you have find some outliers which do not belong to that data set. So what should be the treatment for those outliers, right? Outliers means, so let's suppose you just take an example, a simple example. So you are maintaining a data of people having a age group of 18 years to 50 years, right? But let's suppose a entry or two, three entries in that data is of year 75, 76 years, even more than that, right? So these are outlier for this data set, right? Which is very far from your mean of overall data you have, right? So these are the outliers for. So how to treat those outliers, right? So visualization. So you do multivariate analysis, you do bivariate analysis, right, of data, and do the visualization, and how one factor is dependent on other factor, right? One feature is dependent on other feature. How tightly those features are affecting, how tightly those features are affecting each other, right? So this is one of the skill, right? You need to showcase when you are working in a used data, right? And defining the correlation between the features, right? Different features. So when I say features means for a developing a data science solution, you just filter your first attributes you are looking into, right? So let's suppose you are trying to run a campaign, ad campaign, right? So your feature may be that for which age group you are running this ad campaign, right? Your feature may be the for which location. So location, age, these are features, right? So you need to understand those features as well, right? How they are correlated, right? And then uh, now I'm giving example of the finance domain. So I stick to this, that let's suppose you have a huge set of data, of banking customers, their transactions, how they are how they are doing banking with the your how they are doing banking with the bank for which you are developing this solution, this data science solution, right? So ultimately you have to help, if as a data scientist you have to help the bank deliver the target offers. What kind of offers you can give to your customers so that you can increase your sale, right? Increase your customer base, increase your investment uh, by the customer in your bank, right? So what kind of offers you can derive, so right, so you need to do the economic analysis of the bank, you have to do the risk analysis, right? So if I go with this offer, if I go with this new new product, so what are the risks associated for the customer as well as for the bank, portfolio management of the customers, right? Loan portfolio of the bank, right? And the industry risk assessment standards, right? So the banking system works on a standard as well, right? So what the industry is doing, and in comparison of that, uh, where your offer will fit into, right? So you need to think about that as well. So these are the day-to-day work it, you as a data scientist or a data engineer is thinking thoroughly, right? To come up with a new product or new offer for your customers, right? So this is again a day-to-day work. So first, continuous knowledge acquisition. Second, exploratory data analysis. Third one is helping bank to deliver the targeted offers for the customers or even for bank, right? Then last but not the least, you have to showcase all these learning from data to the stakeholders who are actually deciding, who are the decision makers, right? So what should be the elements for developing the dashboard for those people who are actually the stakeholders, right? So what are the elements for that dashboard? So you create a dashboard. So you do not go with the files, or you cannot go randomly in front of those people and saying that we need to develop this, right? So this doesn't happen. So you need to present that, and for that presentation, as a data scientist, as a data science engineer, you have to build a dashboard around it, right? So there should be a clear problem definition of what you are going to solve, right? Supporting data visualization, right? So from that data you have inferred something, that visualization should be in a form of in a form which a stakeholder can understand. So no technical language in that, right? Business outcome. So what uh, as a business I'll get when I will go with this offer, right? And then what will be your market spend, marketing spend, uh, and the revenue predictions after that market spend and marketing spend. So this analysis you have to go with in front of your stakeholders. Yeah? Working capital and liabilities. What are your current working capital? What are the current liabilities, right? Risk indicators after applying this new offer, or you can say new product, or launching this new product, right? So what can be the risk indicators, right? So these all things daily the data science and data engineer thinking in their mind, right? So based on their experience, right? I'm not saying from very first day you will be thinking this, but as soon as you are traveling to that journey, you will surely able to map all these things in your mind when you are moving in that journey, right? So this is how the day-to-day work of a data scientist is planned, right? So I hope you able to understand it. So it's a huge spectrum. So the next question comes is, so if I want to start as a data scientist, so what should I do? So I'll take care of this question at the in my next session, or in my next video. So see you there, and thank you so much for watching.